A 6-meter ladder is leaning against a wall. If the base of the ladder is pulled away at a rate of 0.5 meters per second, how fast is the top of the ladder sliding down the wall when it reaches a height of 5 meters? So we want to start by drawing a picture. In this case, we have a 6-meter ladder that's leaning against a wall. And we are making some assumptions. We're assuming that the wall is perpendicular to the ground and that the ground is level. And we want to begin by labeling our picture and identifying what quantities are changing and what quantities stay the same and are constant. So in this case, the ladder's length is always going to be 6 meters. So we'll go ahead and put the 6 meters on our diagram. However, it says that the base of the ladder is being pulled away from the wall. So the base of the ladder is going to be moving this direction. And as that happens, that means that the top of the ladder is going to be sliding down the wall, moving this direction. So I always like to add arrows to indicate direction of movement on my diagram. Therefore, both of these quantities are changing. The distance between the base of the ladder and the wall, as well as the distance between the top of the ladder and the ground. So we need to go ahead and label both of those quantities with variables since they are changing. And it does not matter what letter names you choose. You can use X and Y. Some people like to use B for base and H for height. It is entirely up to you. Now, there's some additional numerical information in the problem that we also want to write down. For example, it says that the base of the ladder is being pulled away at a rate of 0.5 meters per second. So that's a rate. That tells us that that's going to be a rate of change, which means it is a derivative. In this case, that's telling us how fast the base is changing in this diagram. So we would label this as dB dt. So dB dt is equal to 0.5 meters per second. Now, we were also given the information about the height being 5 meters. However, the height is not always 5 meters, so this does not remain constant. The height will only be 5 meters at a specific instance. So I'm not going to include the 5 meters on my diagram because the height is not always 5 meters. Now we're ready to write down our find statement. And many times our find statement can be written in this form: find blank when blank. This is kind of an easy structure to begin with. So the problem says we want to find how fast the top of the ladder is sliding down the wall. So that's going to be a rate. That's the rate in which h is changing. So we will label that as dh dt. So find dh dt when the ladder reaches a height of 5 meters. In other words, when h is equal to 5 meters. So now we're looking for an equation that relates all of our variables. And in this case, since we have a right triangle and we are interested in all 3 sides, we can use the Pythagorean theorem. So b squared plus h squared is equal to 6 squared, or 36. Once we have an equation that relates all of our variables, then we're ready to go ahead and use implicit differentiation to find the derivative. Now remember, what we're trying to find is dh dt. That means that we want to differentiate with respect to time. So we're going to take the derivative with respect to time, but we're doing that implicitly. So the derivative of of b squared is going to be 2b, but then we have to chain on the derivative of b with respect to time, which is dB dt, plus the derivative of h squared is 2h, chaining on dh dt, and then the derivative of 36, being a constant, is 0. Now we can pretty much substitute in the values that we were given and hopefully be able to solve for dh dt. So I'll begin my substitution. We have 2 times b, and you'll notice I don't have any information right now about the value of b, so I'm going to kind of leave that blank, times dB dt, and we knew that dB dt was 0.5, plus 2h, we were interested in when the height of the ladder was 5, so at the instant that h is 5, and then we're solving for dH dt, that's what we were trying to find. So here's what our equation looks like right now. So you can see we're kind of missing this b value. So we need to think about how we can find the value of b when the height of the ladder is 5. So if you go back to your diagram, over here, we had a right triangle. So basically, it's as if we're trying to look at the instant when the height is 5, the length of the ladder is still 6, and we need to solve for b. In other words, we need to do Pythagorean theorem on this little triangle. B squared plus 5 squared, which would be 25, equals 6 squared, which is 36. So if we solve for b, then we'll see that b will be the square root of 11 at that instant. And we want to go ahead and leave that exact. So we'll go ahead and put the square root of 11 here into our equation. You don't want to round multiple times in these problems. You want to round one time at the very, very end. So 2 times a rad 11 times 0.5 will end up being just plain square root of 11. Plus 2 times 5 is 10, so 10 dh dt equals 0. So if we subtract the square root of 11 and divide by 10, we'll end up with that dh dt is equal to negative square root of 11 divided by 10. And that would be our exact answer. And of course, we can go to our decimal equivalent if we want to using our calculator. And that would be about 0.33. And then, of course, we need units here. So going back to our diagram, h was a height, and the height was measured in meters. So the rate at which the height is changing would be meters per second. And then I always want you to pause at the end and see if your answer seems feasible. In this case, we ended up getting a negative answer for this rate. But again, back to our diagram, notice we had arrows indicating that the ladder was sliding down the wall, so we would expect to have a negative rate for h, since h is decreasing. So a negative rate makes sense. And then you could go ahead and write kind of a summarizing sentence at the end. What we just found is that the ladder is sliding down the wall at a rate of about 0.33 meters per second when the height is 5 meters.